Yeah, find the 2 points. Always list out your 2 points. What's the first point? 2. Does everyone agree with this point? 2, 9? What's your second point? 2 plus h. And what's the y value for this h value, for this x value?
2 plus h squared plus 2 times 2 plus h plus 1.
There's your 2 points. What are you going to do with your 2 points? Change in y over change in x. The only thing you're going to do. Now, my suggestion to you, Allie, make sure you simplify all of this before you plug it into the slope equation. It'll alleviate errors. Multiply all of this out and always do that. Okay, Jesse? First thing you should always do, if it's an average or instantaneous problem, write your 2 points. Because that is just y2 minus y1 over x2 minus x1. Always. But if there's some junk like this, clean it all up. Combine your like terms. It'll just make your life easier, David, okay? When you combine your like terms, what do you get here? What does this simplify to?
H squared plus 2h plus 9.
Do we agree with that?
I got 6h.
I got 6h. Yeah.
Check. Verify. Who's agreeing with who?
Oh, okay. Wait, I see what it dropped.
Is it was it this the 2 going there? Yeah, this would be a 4h out of here, and that's another 2h. It should be 6h.
Yeah, that's why.
Does everyone agree with this? Wait, do you agree that this simplified is h squared plus 6h plus 9? What did you get?
Oh. I was so ahead.
6h plus.
It's just the y value.
No. H squared plus 6h over h. I don't have 9.
Oh, did you already simplify? Did you already plug it into your slope equation? Did you plug it into y2 minus y1 over x2 minus? You shouldn't have anything dividing yet.
I got the slope right.
So I'm just asking. I'm not even close to that yet.
Oh.
Again, what you should do step by step is first thing, write your 2 points. Then just simplify one of the points if there's some stuff here, and then plug in. Now, I'm telling you, if you do that, it'll minimize errors. Okay? It'll minimize. You still might have some from time to time. And this is change in y over change in x is equal to the limit as h approaches 0 of my y2 minus my y1 over x2 minus x1. Always, if you're doing average or instantaneous, y2 minus y1 over x2 minus x1. These cancel out. These cancel out. And again, write your limit every time. Otherwise, you can't evaluate this. H squared plus 6h over h. Then what can you do? Yeah, you can factor an h out of the numerator and cancel it with the 1 in the denominator. Equals limit as h approaches 0 of h plus 6. Now what can you do? Plug what in?
0.
Plug in 0 for h to see where the as h approaches 0, what the slope is approaching, and it's 6. So what does that mean, Marco? I got this number 6.
That the instantaneous rate of change x equals 2 is 6.
For this function, the instantaneous rate of change for the x squared plus 2x plus 1 function is 6 at x equals 2. The slope of the tangent line at the specific x value, 2. Everyone grab this on your calculator. X squared plus 2x plus 1. And just take a look around x equals 2. Does it look like, if you kind of squiggled in a tangent line, does it look like it should be a positive slope? That's one check you can do real quick, you know? Does it look like it would have a positive slope? And is it super steep? Is it like 1? What does it look like? And these are your checks that you can do. Does it look like it should be a positive slope? You know, if you drew it in right here, if you drew in a tangent line, does our answer just overall kind of make sense? Does it? Okay. Let's try another problem. I want to know what the instantaneous rate of change is for the function 5x plus 1 is at x equals 2. I want to know what the instantaneous rate of change is for the function 5x plus 1, what that value is at x equals 2. Do it.